let us continue numerical and solutions. Yesterday I have discussed 5 numericals. Let us continue that portion ahead. Now these numerical are very important. I was discussing numerical based on Henry's law. Still today I am continuing numericals on Henry's law. You read the numerical, it is question number 6. H2S, a toxic gas with rotten egg-like smell, is used for qualitative analysis. If solubility of H2S in water at STP, this value is given, it is 195. Calculate Henry's constant. KH you have to calculate. Partial pressure of H2S is given as 0.987 bar. Clear? Now from here we are going to solve it. 0.195 amp means 0.195 moles of H2S are present in 1000 gram of water. Okay, molality, you know molality, number of moles present per kg of solvent. Here solvent is water, so this amount of H2S is present in 1000 gram of water. Therefore, number of moles of water you can calculate here only. It is 1000 upon 18 and this comes to be 55.5. 55.5. Then mole fraction of H2S will be equal to what? Number of moles of H2S is given, so this will be number of moles of H2S upon number of moles of H2S plus number of moles of water. We have to calculate mole fraction. You know Henry's law that partial pressure is directly proportional to the mole fraction of solute. Okay, you solve it. Mole fraction of H2S is 0.195 upon 0.195 plus 55.5. Okay, let us solve this mole fraction and see what the value is coming. I am solving it. Wait a minute. 0.195 plus 55.5. 0.195 divided by 59.95. It is coming to 0.003. The mole fraction is 0.003. This is mole fraction of what? H2S. Now you apply Henry's law. From Henry's law, you know Henry's law very well. Partial pressure is equal to Henry's constant multiplied by mole fraction of H2S. In this numerical we have to calculate KH. Therefore, KH, Henry's constant, will be equal to partial pressure multiplied by mole fraction of H2S. Okay, now you substitute the value. Partial pressure is given of H2S. It is 0.987 upon mole fraction 0.003. You solve it, you will get the answer for this. It is 0.0034. Write the complete value 4. Okay. Now when we are solving it, we will get the answer. It is coming to be approximate 282 bar. 282 bar. So this is Henry's constant for this equation. This is Henry's constant for this equation. Okay. Understood? Clear? So this was one numerical, it was question number 6. Let us move on to next question. Question number 7. Now you read the question. Henry's law constant for molality of methane in benzene at 298 Kelvin is this. Calculate the solubility of methane in benzene. You have to calculate methane solubility in benzene. Henry's law constant for molality. Okay, then from Henry's law. You know Henry's law very well.
उसको मिटा दो तो बाद में सही वाला है अपना गायब हो जाएगा फिर नीचे स्क्रॉल करना
ठीक है
वो फिर
For Henry's law, molality of methane in benzene is given. Calculate the solubility of methane in benzene. Okay. Pressure is given, that is 760 mmHg. Now you know Henry's law. Henry's law states that what? Mass of a gas or pressure is equal to Kh into solubility. This solubility corresponds to mole fraction. You know very well. Therefore, we have to calculate what? Solubility. Therefore, solubility will be equal to P upon Kh, partial pressure upon Henry's constant. What is the partial pressure? 760. And the value of Kh is given 4.27 into 10 to the power 5. You solve it, you will get solubility of this. So the solubility of this is coming to be 1.78 into 10 to the power minus 3 bar. This is solubility. Okay, here this solubility, you know, it corresponds to, it relates to what? Mole fraction. You should be familiar with this. Solubility relates to mole fraction. So I have solved the answer. It is 1.78 into 10 to the power minus 3 bar. This is the solubility of what? Methane in benzene. Each and everything is given. You can solve it. This is a direct numerical. Clear? Now, let us move on to our next question. Question number 8. Now this numerical is very important. You see the numerical carefully. The vapor pressure of pure liquid A and B, their pure vapor pressure are given 450 and 700 mmHg at 350 Kelvin respectively. Find out the composition of the liquid mixture if pressure is 600 mmHg. Also find composition in vapor phase. Clear? You see the question. The vapor pressure of pure liquid are given. We have to find the composition of liquid mixture if total pressure is 600. Composition means XA and XB. Let mole fraction of liquid A is equal to XA. Similarly, mole fraction of liquid B is equal to, 1 minus XA. Clear? Therefore, from Raoult's law, you know Raoult's law very well. Total pressure P is equal to P naught AXA plus P naught B XB. This is Raoult's law. Okay, this total pressure is given. It is how much? 600. So this is 600 is equal to P naught A. It is given 450. 450 multiplied by mole fraction. Mole fraction is XA plus PB 700. And what is mole fraction of XB? 1 minus XA. Solve it. 600 is equal to 450 mole fraction XA plus 700 minus 700 XA. Okay, solving it, 700 comes over here. So 600 minus 700 is equal to minus 250 XA mole fraction. Okay. This is minus 100 is equal to minus 250 XA. Minus minus get cancelled. Mole fraction XA, it comes to be 100 upon 250. You solve it, it is 0.4. So XA is 0.4. Understood? Now, what about XB? Therefore, mole fraction of XB will be equal to 1 minus 0.4. This will be equal to 0.6. So we have calculated mole fraction of both. In this entire mixture, mole fraction of XA is 0.4, XB is 0.6. Now what we have to calculate? Find composition in vapor phase. Now I am solving over here. Let us see. Okay. Therefore, PA will be equal to P naught A XA. P naught A, what is P naught A? 450 multiplied by mole fraction of XA 0.4. This comes to be how much? It is coming to be 4 5 20, 4 4 16, 17, 18, 180. This is 180 mmHg. Okay. Similarly, PB, partial pressure of component B will be equal to P naught B XB. P naught B is 700 multiplied by mole fraction 0.6. This will be equal to, multiply it as 420 mmHg. Clear? We have calculated partial pressure of both components. That is what? Partial pressure of A and partial pressure of B. Now what is to be left? The question is here. Where to find the composition in vapor phase? So how to get composition in vapor phase? How will you get composition in vapor phase? Okay. Now, composition in vapor phase. Let us remove this 180, 420. Then composition in vapor phase. Composition of A in vapor phase. In vapor phase, composition A in vapor phase will be equal to the partial pressure of this upon total pressure. So what was its partial pressure? 180 and total pressure was 600. You solve it, you will get its composition in vapor phase. This is coming to be 6 3 18, 0.3. Similarly, composition of B in vapor phase. Vapor phase, this will be equal to entire partial pressure of B, and its partial pressure was how much? Just we have calculated 420 upon total pressure 600. And this is coming to be 0.7. So these are the answer of this question. Clear? So first we have calculated what? We have calculated the mole fraction of component A and component B. Then we calculated their partial vapor pressure. After partial vapor pressure we calculated their total composition. Clear? This numerical should be very clear to you. It is an important numerical. Okay, let us move on to next part. Next numerical, question number 9. This is question number 9. You see the question. The partial pressure of ethane over a solution containing 6.56 into 10 to the power minus 3 gram of ethane is 1 bar. If solution contains this much of ethane, then what shall be the partial pressure of gas? We have to calculate partial pressure. Okay, now let us solve it. You know Henry's law. Henry's law. What is Henry's law? You are familiar with this Henry's law. Mass of a gas dissolved in a liquid is directly proportional to the pressure applied by liquid gas over the surface of liquid. This is Henry's law. Mass is given 6.56 into 10 to the power minus 3 is equal to kH into pressure. Here is pressure 1 into 1 bar. Okay. So therefore, what is kH? kH value has come this into 10 to the power minus this. kH multiplied by was this is value of kH, equation number 1. Then let us move on the same equation. Suppose m dash is equal to kh multiplied by p dash. In second part, this is the mass. So mass is 5.00 into 10 to the power minus 2 kh. From equation number 1, we have got kh 6.56 into 10 to the power minus 3 multiplied by partial pressure. This you have to calculate. Therefore, P partial pressure will be equal to what? It is 5.00 10 to the power minus 2 upon 6.56 into 10 to the power minus 3. You solve it, we will get the answer of this question. And this is coming to be 762 bar. This is the answer. It's a very simple question. It is a 1 mark question. It is 762 bar. First we calculate kh from first part kh. From here kh was calculated. Putting the value of kh in this. Okay, this. Putting kh. Putting the value of kh. that is putting the value of K as Henry's constant. We have got the values of Henry's constant, it is this. If we will calculate partial pressure, so what is the partial pressure? Partial pressure of gas is equal to this 762 bar. Clear? It is a simple question, it is a 1 mark question. Understood? These numericals should be clear to you. Let us move on to next numerical. Now let us see this. Now these numericals are very long. Okay, you see, read the question carefully. 100 gram of liquid molar mass was dissolved. First part is this 100 gram is dissolved in this. 1000 gram is dissolved in this. From here we will calculate first number of moles of both and their mole fraction. Clear? Let us solve it. Let Na and Nb the number of moles, of liquid A and B, okay, liquid A and B. Now moles A, Na, therefore Na will be equal to what? 100 gram upon molar mass is 140. You solve it. What is Na? What is the number of moles? Let us solve this. 100 upon 140, 10 upon 40, that is 0.714. The number of moles, this is 0.714. Clear? Similarly, Nb, number of moles of Nb. Nb is how much? 1000. It is dissolved in 180. Molar mass is 180. Okay, let us solve its mole fraction, number of moles. So this is 100 upon 18, 5.55. This is 5.55. First part is this, we calculate number of moles of both components A and B. Then mole fraction. Let us calculate mole fraction of both. Then XA, mole fraction XA, component A, this will be Na upon Na plus Nb. Or this mole fraction will be equal to what? It is 0.17714 upon 0.714 plus 5.55. Let us solve this. What is this coming? Mole fraction. It is 714.714 plus 5.55, 6.264. This is equal to 0.714 upon 6.264. You will get mole fraction by this. Let us divide it. On dividing, we will get what? 0.714 divided by 6.264. 0.714 divided by 6.26. It is coming to be 0.114. This is mole fraction of XA. Therefore, XB, you can calculate XB. XB is 1 minus XA. So this is 1 minus 0.114. And this is equal to what? You solve it, you will get the answer for this. 1 minus 0.114. This is 0.886. 0.886. Now this is the second part. We have calculated mole fraction of both XA and XB. Now you come to the next part. The vapor pressure of B was 500 and total vapor pressure was this. This you have to calculate. Okay, then let us solve it over here. From Raoult's law. You know Raoult's law. What is Raoult's law? P total is equal to P naught A XA plus P naught B XB. Yes or no? P total is given 475 is equal to this. You have to calculate P naught A. Here it is written. Calculate vapor pressure of pure liquid A. This multiplied by XA. Where is XA? This multiplied by 0.114 plus P naught B is 500 multiplied by mole fraction 0.886. Solve it. 475 is equal to 0.114 P naught A plus you multiply 500 by just that value. Okay, let us multiply it, and what is coming into 500? This coming 443 plus 443. Clear? Up till here there should be no problem. Okay, now we have to calculate from here. You can calculate P naught A. Let us rub it and then try to calculate P naught A. 475. Okay, now 475.114 P naught A is equal to 475 minus 443. You will get how much? 0.114 P naught A is equal to 7. 5 minus 3 2 732. Therefore, P naught A, we have come to our answer 32 upon 0.114. You divide it, you will get the answer for this. This is coming to be 280.7 P naught A. This is 280.7 bar. Now you see, this is partial pressure of what? This we have solved, pure liquid A. Calculate the vapor pressure of pure liquid A and its vapor pressure in solution. One more part is left. Okay, now therefore PA is equal to, in solution, pure vapor pressure multiplied by its mole fraction. Pure vapor pressure is this 280.7 multiplied by XA. Mole fraction of XA is this 0.114. You multiply it, you will get the second part also. This is 32 torr. The answer is in torr. Here also you can write torr instead of bar. Okay. It is 280.7 torr. I have written bar, you can omit it, it is torr. So this is how this question was solved. First we have calculated what? Mole fraction of both components. Then we applied that mole fraction in Raoult's law. From Raoult's law we calculated pure vapor pressure of A, and from this pure vapor pressure we calculated vapor pressure in solution. Understood? So the question has 3 parts. It was divided into 3 parts. Clear? Now let us move on to next question. Question number 11. You see question number 11. Two liquids, there are two liquids, X and Y, they are forming an ideal solution. This question has two parts. The vapor pressure of solution containing 3 mole of X and 1 mole of Y is given. Second part, 4 mole of X and 1 mole of Y is given. Vapor pressure of pure, we have to calculate pure vapor pressure of X and Y. Understood? Now let us solve this. What will be the vapor pressure of pure X and what pure Y? Let vapor pressure of X and Y be P01 and P02 and their mole fraction of both mole fraction be X1 and X2. Okay, this is vapor pressure of X and Y are P01, P02. Their mole fraction be X1 and X2. Therefore, from Raoult's law, from the law, from Raoult's law, you know very well P total will be equal to what? P01 multiplied by X1 plus P02 multiplied by X2. Yes or no? We have assumed their vapor pressure and mole fraction. Then first condition, from here we will move on our question. 3 mole and 1 mole. Clear? Case first. In case first, 3 mole of X, 1 mole of Y were mixed. Yes or no? Then mole fraction of, you have to calculate what mole fraction of X and mole fraction of Y. So X1 is equal to what? 3 upon 3 plus 1. This is equal to 3 upon 4, 0.75. Similarly, X2. This X2 will be equal to what? 1 upon 3 plus 1. It is 4. This is 1 upon 4. This will be 0.25. We have calculated mole fraction of both components in case 1. Now you apply this. Therefore, what is P total for first? 550 mm of Hg. Clear? 550. Instead of this, we will write 550 is equal to P01 multiplied by 0.75 plus P02 multiplied by 0.25. Question number 1. Clear? This is case 1. Similarly, you frame another equation for case 2. Let us see what is coming for case 2. Case 2. This is case 2. What was case 2? When 4 mole of X and 1 mole of Y are mixed. Here also we calculate X1. Mole fraction of component X. It is 4 upon 1 plus 4. It is 4 upon 5. Okay. And this is equal to what? 0.8. Yes or no? Similarly, we will calculate X2. Here I am calculating X2. So X2 will be equal to what? 1 upon 1 plus 4. This is 1 upon 5. And this will be 0.20. Clear? From second case also we have calculated mole fraction of both. Mole fraction of what? Mole fraction of x and mole fraction of y. This is to be applied in this. Therefore, what was the total pressure in second case? 560. Here we frame second equation. 560 is equal to P01 multiplied by 0.80 plus P02 multiplied 0.20, equation number 2. Clear? Now let us solve the entire question. We have got two equations, equation number 1 and equation number 2. There are two equations here which I have written. Now from this equation you will solve. Now where is equation number 1? This is equation number 1. So multiplying 1 by 4 and 2 by 5, multiply equation 1 by 4, equation 1 by 4 and equation 2 by 5. Okay, you multiply this equation 1. This equation is to be multiplied by 4 and this equation is to be multiplied by 5. You multiply it. 4 5 are 20, 22 is equal to what? 75 4s are 300. So this is 3 P01 plus 25 4 to 100 is 1 P02. 5 you multiply this by 5 0. 5 is the 33. 5 5 is 25 and 3 28 is equal to 8 5 is 40. So this is 4 P01 plus P02. You multiply 25 is 100, it is coming 1. Now you solve this. You get two equations, minus cancelled. This is minus 600 is equal to minus P01. Minus cancel. You have got P01, partial pressure you have got. Okay, now let us rub this. We have got what? We have got P01 means pure vapor pressure of X is equal to how much? 600 mmHg. Now one part is left of Y. You can calculate Y. Putting the value of this here, we will get P01 is equal to 600. Put this in any equation. Putting the value in equation 1. You write this value in equation 1. Put the value in equation 1. Where is equation 1? This is equation 1. You put the value of P1 here. You will get 2200 is equal to 3 multiplied by 600 plus P02. This is 2200 3 6 3 18 plus P02. So P02, this will be equal to 2200 minus 1800, 400. So what is P02? Here we have come. Therefore, this is equal to 400 mmHg. We have got our answer for both parts. So, pure vapor pressure of component Y is equal to 400 mmHg. Clear? Now this numerical should be clear to you. That's why we are doing a numerical of solutions. Understood? We have put the value of P01 in this equation, and from here we will get the value of P02. What was P02? It was pure vapor pressure for component Y. P01 was vapor pressure of component X. Understood? Now let us move on to our next numerical, numerical number 12. Now you see numerical number 12. The vapor pressure of water is given. This is vapor pressure of water. Calculate vapor pressure of 1 molar solution. Clear? So 1 molar solution means 1 molar solution means 1 mole of solute is present. Molality is present in 1000 grams of water. In 1000 grams of water. Okay. Clear? Now number of moles of solute. Let Na and Nb are number of moles of solute and solvent. Solute and solvent. So we know, therefore this is given, number of mole of solute is equal to 1. It is already given 1 mole. Here it is written 1. Then number of mole of water will be equal to 1000 gram of water upon its molar mass. This is equal to 55.5. We have calculated number of moles of both. Therefore, mole fraction of solute Xa will be equal to 1 upon 1 plus 55.5. This is equal to 1 upon 56.5. Let us solve it. What is mole fraction of Xa? I am solving it. Wait a minute. 1 divided by 56.5. It is 0.0176. 77 we can write, no problem. 77 this has come. We have to calculate vapor pressure of solution. Clear? When? From here we will calculate it from which formula? P RLVP, relative lowering of vapor pressure. P minus PS upon P is equal to mole fraction of solute. What is P? P is given pure vapor pressure. 12.3 minus PS. This you have to calculate. This is given, and mole fraction of solute we have calculated just. That is how much? 0.0177. Now you solve it. So 12.3 minus PS is equal to 12.3 multiplied by 0.0177, or 12.3 minus PS is equal to, let us multiply it and get what is coming. 12.3 multiplied by 0.0177, 2.177, 0.2177. Okay, therefore PS will be equal to 12.3 minus 0.2177. You will get the answer 12.08 kilopascal. This is what you have to calculate. 12.08 kilopascal. This was the vapor pressure of solution, and vapor pressure of solution is always less than vapor pressure of pure solvent. Clear? This numerical is very simple. Okay. Now let us see last numerical for the day. Calculate the mass of a non-volatile solute, molar mass, which should be dissolved. Vapor pressure reduced to 80%. There, let us solve it. When vapor pressure is reduced to 80%, then P minus Ps upon P. Okay, and this will become what? Initial 80% 100 minus 80 upon 100. This is 20 upon 100. This is 0.2. This is the reduction in vapor pressure. Clear? Now let us solve it. After this, I am solving it over here. Therefore, P minus Ps upon P is equal to WA upon molar mass. Let that molar mass be X upon WA upon X upon WB upon and B. Here I am writing, calculate the mass of molar mass is given. X upon ME, X upon MA. Let X is the mass of solute which you have to calculate. X is the mass of solute. Okay. P minus Ps upon P was 0.2. 0.2 is equal to X. What is molar mass of solute? 40 upon X upon 40 plus 114 gram, and molar mass of octane is also 114. So 0.2 is equal to X upon 40, X upon 40 plus 1. Cross multiply it. Here I am getting it 0.2 and it is 1 plus X upon 40 is equal to X upon 40, or 0.2 is equal to X upon 40 minus 0.2 X upon 40. You solve it. 0.2 LCM is 40. This is X minus 0.2x, 0.8x. So 0.2 is equal to 0.8x upon 40. Okay, or 8 is equal to 0.8x. X we are going to calculate, therefore X will be equal to 8 upon 0.8. You solve it, you will get the answer. Your answer will be 10. So what was the molar mass of solute? 10 grams. This we have calculated. It is 10 grams. Understood? This is how this numerical is to be done. Okay. That's all for today. We will continue it tomorrow. Thank you very much.